So today we're going to work on some guided notes about quadratic functions. So the graph of a quadratic function is called a parabola, and there are three forms of the quadratic equation. That's standard form, vertex form, and factored form. We've looked at standard and factored before, but today we're also going to add the vertex form. If the a in any of our functions is greater than 0, the graph is going to open up. If the a in any of our functions is less than 0, the graph is going to open down. All quadratic equations have a vertex, which is the turning point of the graph. Quadratic graphs are symmetrical across the axis of symmetry, which runs through the parabola. The formula for the axis of symmetry is a plus b divided by 2 in factored form. Or we can always say that the axis of symmetry goes through the vertex. So it's the x-intercepts of the graph added together and divided by 2. A quadratic function crosses the y-axis once, and the y-intercept always has an x value of 0. For a parabola, the y-intercept will be the point 0, 0. So the standard form of our parabola has our y-intercept on 0. A quadratic function crosses or touches the x-axis either 0, 1, or 2 times. So examining the graph below here, we want to identify the vertex, which is about at the x value of 1. Our axis of symmetry, again, is x equals 1. The y-intercept is 4, and the x-intercepts are negative 1.5, positive 3.5. So we're just looking for those key points on our graph. Graphing in standard form allows us to utilize coefficients to solve for the axis of symmetry. Axis of symmetry equation is negative b over 2a. So we solve for what that x value is, and then we plug that into our equation in order to determine the y value, and that will tell us exactly where our vertex is. So looking back at the equation, I can identify my a, b, and c values. A is 4, b is negative 8, c is 1. So I know my a is positive, my parabola is going to open upwards, which means that it has a minimum value, and the axis of symmetry is at x equals 1. My vertex is at 1, negative 3, and I found that just by plugging the 1 into my equation for x and solving for y. The y-intercept, if I plug into my equation that the x is equal to 0, that would give me my solution for the y-intercept. So when I plug in 0 for my x, and then I solve for my y, 0 cancels out my first term, my second term, and I'm left with a positive 1. So in order to find that third point, I'm just going to reflect my y-intercept over the axis of symmetry. So that gives me a third point because obviously my parabola is always symmetric. For this one, I'm asking you to try it on your own, but obviously you can follow along with me if you'd like. I'm just identifying the a, b, and c, determining what direction my parabola is going to open, figuring out where my axis of symmetry is going to be, drawing it in, solving for the y value, solving for the y-intercept, and then solving for that third point, which will reflect over the axis of symmetry, but be symmetric to my y-intercept. So this is all just plugging in for x, solving for y, identifying those key points, and graphing the function. Now moving on to vertex form. This is the new form. It's asking me to find the vertex and find A. Well, in this particular form, my vertex is always my H, but it is a there is a negative in that equation, so you do have to find the opposite value of my H and my K. So the A value obviously is just the term that's out front. It tells me whether my parabola is opening up or down, whether it has a minimum or a maximum. All of those things help me in graphing my quadratic functions. So once we know where to find the key information in our functions, the process for graphing a quadratic is pretty much the same. It's really, where's your axis of symmetry? Where on the axis of symmetry will your vertex be? Where's your y-intercept? And then reflecting that y-intercept over the axis of symmetry to get your third point. So a lot of this is pre-algebra calculation work. So I'm going to speed through the next couple of examples. Obviously, if you need more of a visual, go ahead and pause, record your responses. We're going to move on to the factored form. Again, this is something that we practiced a little bit, where we recognize P and Q as our x-intercepts, or the zeros of our quadratic, and the axis of symmetry can be found using P plus Q divided by 2. So what is the midpoint of those two coordinates? Now, our P and Q both do have a negative sign, so we need to take the opposite of whatever the value is that we see in the function. So you'll notice that my -1 turns to a +1, +2 turns to a -2. I'm just taking the opposite, and then using that to find the axis of symmetry. We always identify our A, figure out which direction the parabola is going to go in, find our axis of symmetry, plot the vertex, the x-intercepts, the y-intercept, and a reflected point. Now again, I'm going to kind of speed up because this is the pre-algebra calculation kind of phase of the game. So as long as you have these notes completed and you have some accurate examples, you should be all set and ready to go. Thanks, guys. Make sure to ask any questions if you have any after your guided notes are completed.